Hello all, and welcome to this video where we'll solve a trigonometric equation problem from the IBSL past papers. So in this question, we have a function f of x equals radical 3 sine x plus cosine x, and another function g of x equals 2 of x, and they have different domains. So for the f of x, the domain is from 0 to pi, and for g of x, the domain is all real numbers. Now, in question A, we're required to find f of g of x. F of g of x means a composite function. So I like to write it in a different way. Makes me solve it in an easier way, understand it in an easier way. So I'm just going to say that f of g of x equals f of, and then I substitute g of x with the value that I'm given in the problem. And here, this is 2 of x. This is 2x, excuse me. So now, instead of f of g of x, I'm going to write f of 2x. And then I'm going to go ahead and substitute every x in the original function or the outer function, which is f of x. I'm going to go to every x and substitute that with 2x. So now I have radical 3 sine 2x plus cosine 2x. And we're done with question A. Question A simply required us to find find an expression for f of g of x. The two notations are equivalent, so the way they wrote it and the way we wrote it are pretty much the same. But I find that this way just makes more sense. It's better visually to understand what we're doing. We're sort of putting g of x inside f of x by replacing every x by the corresponding g of x value, which is 2x. So for question B, we're required to solve an equation f of g of x equals 2 cosine 2x. So let me first clean up a bit. Now for B, we're required to equate the value we found in A with 2 cosine 2x. So let's try to go ahead and do that. We'll just write the same expression we found before, radical 3 sine 2x plus cosine 2x equals 2 cosine 2x. We're equating the expression we found in A to the expression they gave us in B. And we are required to solve for x. Now, in order to solve for x, let's first try to simplify a little bit. Let's take the cosine 2x to the other side maybe and subtract. So we get radical 3 sine 2x equals cosine 2x. Next step would be one of two things. You might be tempted here to think of using double angle identities and trying to expand all of this and get another expression that doesn't have 2x, that just has x, sine x, cosine squared x, and so on. This would be a mistake because there is a much shorter path here where you simply divide both sides by cosine 2x, and that gets rid of one side, and another side is transformed into an expression I can work with. So if I divide both sides by cosine 2x, what I get is the following. I get, on the left, I get radical 3 tan 2x And on the right, I just get 1. Because anything divided by itself is 1. So this is fairly simple. Note that normally you're not encouraged to divide both sides of an equation by x, because if x is 0, then you get an undefined expression. So what we did only works if cosine 2x is not equal to 0. You should know that cosine pi over 2 is 0. So we should make sure that 2x is not equal to pi over 2. In other words, we should make sure that x is not equal to pi over 4. If x, for any reason, ends up being pi over 4, then we have to reject this answer, because this answer would give us an undefined expression. Going back to our problem, let's isolate tan 2x in order to start solving for x. So tan 2x is equal to 1 over radical 3. Now, this is a paper 1 question, which means that you do not have a calculator and you need to know the exact value of trig functions in order to be able to proceed. Now, from the unit circle or from special right triangles, you should be able to figure out what value of tan theta gives, you should be able to figure out what value of theta gives tan theta equals 1 over radical 3. So let's draw the two special right triangles that we're aware of, or should be aware of. Now we have here 30, 60, and 90, of course, 45, 45, and 90. And the ratios are 1, radical 3, and 2. Here the ratios are 1, 1, and 2. And radical 2, excuse me. So I want to find an angle whose tan value is 1 over radical 3. Of course, using the SOHCAHTOA rules, we know that TOA means that tan theta equals opposite over adjacent. So where are the opposite and adjacent values that I want? In which triangle do I look for them? So I want to get 1 over radical 3. So I would like to go to the left triangle, and this would be my opposite, and this would be my adjacent. Of course, these values correspond to 30. So 30 is the value or the angle whose opposite is 1 and whose adjacent side is radical 3. And this tells me that theta is equal to 30. Or in other words, tan 30 equals 1 over radical 3. Now, assuming this makes sense to you, we can move on to find the value of x. You can take a screenshot because I'm about to erase the left-hand side of the solution. We're required to find x that satisfies equals 1 over radical 3. And we've found that tan 30 is equal to 1 over radical 3. How does this help? This tells us that 2x is equal to 30. And in this case, we need to convert it to the radian value. Now, how do we convert degrees into radians? we either memorize the formula, which I do not prefer, or we just use a ratio. So we know that pi radians are equivalent to 180 degrees. So 30 degrees would be equivalent to something in radians, and that something by cross multiplying would be 30 pi over 180, or in a simplified way, it would be pi over 6. Let's get rid now of that diagram. We now know that 2x is equal to pi over 6, and this tells us that x is equal to pi over 12 by dividing, of course, by 2. Now, this is not the only value of x that I can get. There is another value, and I need to use the asterisk rule in order to find that. So in the asterisk rule, we know that in the first quadrant, where everything is positive, the value is just the value I get by applying inverse trig, tan inverse 1 over radical 3, which gave me 30 using the special right triangles. Now, in the second quadrant, so this is like the calculator value, or if you're in a non-calculator exam, this would be the value you get using special right triangles. Now, for sine theta for quadrant 2, this is the 180 minus theta quadrant, or the pi minus theta quadrant if we're working in radians. For tan, this would be the 180 plus theta quadrant, or the pi plus theta quadrant. For cosine, this would be the 360 minus theta quadrant, or the 2 pi minus theta quadrant. Here we're working on tan, so we choose this equation, or this modification, I guess. Now, do we add pi? No, we don't add pi. We add pi divided by the number that we have next to the x. So here we have 2x. So instead of adding pi to this value, we can just add pi over 2. And this would give us 7 pi over 12, and that would be my second value. Now, my domain exists between 0 and pi, so I should check whether there are any extra values by adding the period. So what is the period here? The period in normal cases is 2 pi. But again, I have to divide by the number next to the x. So I divide by 2, and then that gives me pi. So I am allowed to add or subtract pi from any of my values and check whether this still gives me something that lies within the domain. But since the domain is from 0 to pi, so with common sense, if you add pi to any value, you'll obviously leave the domain. You'll obviously get outside of the domain. So if you try adding pi to either one of these two solutions, you're going to exceed the domain. Of course, if you subtract pi as well, you're going to get a negative value, and that's also outside of the given domain. This concludes our problem. Thank you very much for your attention.